Hello everyone, this is regular expressions in Pakistan form. I hope I'm pronouncing that right. Probably not. What we start with is we'll start with regular expressions. Regular expressions are used in lexical analysis to find such keywords as int, main, void, or the return function. And Pakistan form is syntax analysis parser. This does more of a broad scope of your compiler work. And we'll get into that after the regular expression examples. So we start off with a regular expression. Let's say we start off with we want 0. I like to put the regular expressions in brackets. 0 through 9. And we only want 3 numbers. This will do that. This will search only for 0 through 9, 3 numbers. So we'll say that is like what 444. It could be 333. Anything such, any digit. Or we can have repeating. If we use a star function, we can use repeating. So this would be 0 through 9, just repeating 9, like this. Now I'm going to throw something more complicated. Let's say we want the start of this program to start with A through Z. A through Z, we can have capital. Let's say we want capital A through Z, capital A through Z. So the start of this expression must start with a capital A through Z, and let's allow this only to be 5 letters. Okay? So then we would like the end of this program to be, let's say, any number repeating. What we'll do is we'll do some brackets and we'll say dash D, which stands for any number, any digit actually. And then we will add the repeating star, and end of file is the money symbol. And this is how you create a simple regular expression you can create. Let's say for email syntax, if you want the correct email syntax, you can do more mathematical equations, or just finding, let's say, the printf function. So what it does is it finds if printf, well, I just mistyped that, printf, look right up here, and it just, let's say there's, 6 letters in there, so we do A through Z, 6. This will find printf. And that's more or less how lexical analysis works. Now let's move on to BNF. What BNF does is this syntax analysis portion that looks through to do something computational wise. And what this does is it'll say it finds a digit, it can multiply it, it can add it. So let's start off making a regular expression. What we can do is we can type in binary. This will be a binary regular expression. And we do 2 sides of the 2 dots and an equal. And we'll set this to, we can do a digit, which is 0 through 9, no doubles like 22 or 33 or 444. Or digit and binary. Now, what we can do next here is we can go to and give digit some pretense, because digit doesn't know yet what to do with it. Well, what do you do with the digit? So we are just going to make this sweet and simple. Digit can either be a 1 or it can be a 0. 0 or 1, either or. So this allows this program to only do binary. So 0, 1, 0, 1, 1, 1, 0 would work. 1, 1, 1, 0 would work. But if we did 2, 0, 1, 1, 0, no, it doesn't go through because of the number 2, and the digit disallows that. So now let's move on to another example. Let's say we have an expression and we want only a verb or a verb or a noun. Let's say that. And we need to give what is a verb. It doesn't know. We need to explain what a verb is. Or a noun. We'll do a noun as well. So, let's say a noun. What could be a noun? A dog, or a cat, and let's say runs. Or what can the dog do? We can chase. So what we can do here is, what will it print out? So we can print out dog runs. No, sorry, you can print out dog, you can print out runs, you can print out chase, but all it does is it looks for dog, noun, run, or chase. It looks for those. Now, if we added plus here, let's put it between the parentheses. What this can do is it can say dog. No, sorry, it can say runs, chases, or chase. Runs, chase. Because verb plus noun, it's backwards. And you can do much more with BNF than just grammar checks. But that's what it is built for, is syntax analysis, to look for specific digits and numbers to do computation with them. So more like this suggestion. And you can do factoring, multiplication, addition, adding. I would like to give one more example. And this is just simple addition. This is nothing too complex. This is just supposed to be a beginner video. We take the expression and let's give it, it can be a number in there. It can be a number, and it can add another number. Now we need to give some of this pretense. So what's a number? A number is equal to, it can be a digit, which is again 0 through 9, or it can be a digit. Again, trust me, this has meaning, or a number. So this allows a digit, 1 or 6, or 99, or 333, or 1,301 billion trillion. There is, of course, a limit, and that depends on segmentation. Nevertheless, what this does is we can give this some meaning. We could do 1 plus 1. That's what that will do. But what we can do some to be some more simplification is, well, what's a digit? So a digit, because we didn't give the digit pretense, so it doesn't know what to do. And what we can do is we can do 0 through 1, 2, or 5. So this allows, the numbers can only be 0, 1, 3, or 5. So we can do 3 plus 5, or 5 plus 3, throw 1 to 0, if we did that. Well, let's remove this, and let's replace this with sign. So what is a sign? Well, we can allow this to do, let's say, addition or subtraction. we can do 1 minus 3, or we could do something like 45 plus 2. And that's just because we gave everything pretense. So this could be anything. You could add in anything you want right here and give it pretense, such as number or sign. Hope this makes sense for everyone, and thank you.